Okay. So everybody close your Chromebooks. We don't need any graphing. So today we're going to start talking about sequences. We're going to learn about an arithmetic sequence and a geometric sequence. Did any of you guys learn about sequences in semester one? Nobody did sequences in semester one when you guys learned about linear functions? Okay. So a sequence is a very special type of function. When students first encounter sequences, they often think of them as just a list of numbers in some particular order. And then they have to find a pattern. We're going to start with the technical definition of a sequence. So a sequence is a function whose set of inputs, which is the domain, is the subset of natural numbers. So I need to talk to you guys about natural numbers. When you learned your numbers, when you first learned how to count, you were little, right? And you started with the number 1. You didn't learn 0 when you were like 1 or 2 years old, 3. You didn't learn 0. So natural numbers are just whole numbers that start with 1. 1, 2, 3, 4, 5, 6, 7, 8, so on. No decimals, no fractions, does not include 0, and it does not include negative numbers, okay? So that's what the domain or the X values for a sequence are allowed to be. A sequence is often shown as an ordered list of numbers. This ordered list of numbers is called terms or elements. And sequence function notation can be tricky. So we use 2 types of notation for sequences. We use function notation, and we also use subset notation. Okay. So we're going to look at this sequence below. God bless you. And we're going to try to represent this sequence with the letter A. So this whole set of numbers here is represented by the letter A. So it says that each number in your ordered list is called a term. So this would be the first term, the second term, the third term, and so on. Does that make sense? Yes or no? Yes. Okay. So when it asks me to find A of 3, this is actually asking me to find the third term. What is the value of the third term? Yeah, A of 3 is 16. This is function notation. Example B says find A of 1 plus A of 7. This means you're just going to take the first term and add it to the 7th term. What is the first term? And what is the 7th term? 256. And 4 plus 256 is 260. Okay. How do we feel about that? Okay, good. All right. This next one is written as a subset, right? This is a subset because we have that like that weird lettering where we drop it down. So A sub 2 is the same thing. It still wants me to find the second term. So A sub 2 equals what? Yeah. A sub 2 is 8. So this next one is also written in subset notation. However, it's asking me to find the first term and do what to it? Yeah, raise it to the second power. So what is the first term of our sequence? 4 to the second power is 16. Good job. Example E asks me to take the 5th term, and from it, what am I going to do? Subtract the 4th term, right? So I need the 5th term minus the 4th term. Well, the 5th term is 64 minus the 4th term, which is 32. equals 32. Good job. How are we feeling about this? Okay. All right. This last one says solve for n. I'm trying to figure out what number of term. So this is like saying what number of term equals 128. What number term equals 128? The sixth term. So that means n equals 6. It's the sixth term. So n equals 6. How do we feel about that? Okay. All right. Sequences are functions. The key here is that the input is simply the numbers placed in the line. And remember that you can't input a number 0 or a negative number. So your inputs are always only going to be 1, 2, 3, 4, 5, 6, 7, and so on. So the input is simply the place of the number in the line, and the output is the actual number in the list in that place. The number in the list in that place. So we're going to look at the sequence. It's got the formula A sub n equals 2n plus 1. A sub n equals 2n plus 1. So write out the first 5 elements of the sequence. So I want you to figure out what happens when n equals 1. Yes or no? N equals 1. What happens when n equals 2? What happens when n equals 3? What happens when n equals 4? And what happens when n equals 5? We're going to show our math. We have to show our math. We're writing out the first 5 elements. So A of 1 equals 2 times 1. So A I'm just trying to get it to let me write. I'm going to shut it off for a second. You guys write it out. A of 1. So we're going to put A parenthesis 1 equals 2 times 1 plus 1. A parenthesis 1 equals 2 times 1 plus 1. Well, that's the same thing as 3. A sub 2, my second sequence, well, that's 2 times 2. I'm just replacing the n with the letter 2 or the number 2 plus 1. And 2 times 2 is 4 plus 1 is 5. A sub 3 equals 2 times 3 plus 1. 6 plus 1 is 7. A sub 4 equals 2 times 4 plus 1. 8 plus 1 is 9. A sub 5 equals 2 times 5 plus 1. 10 plus 1 is 11. So the first 5 elements of my sequence are 3, 5, 7, 9, and 11. Those are the first 5 elements of my sequence. The next question asks me to graph my elements on the table to the right, on the graphing grid to the right. So let's think about this. These are your outputs. The y is your outputs. Remember, the n value or the x is your inputs. So we have a 1, 2, 3, 4, and 5. When x is 1, y is 3. When x is 2, y is 5. When x is 3, y is 7. When x is 4, y is 9. And when x is 5, y is 11. Should we connect those with a line or not? Because it says, why shouldn't we? Can someone tell me why we shouldn't connect those with a line? Has to do with your domain. What did we say the domain was? What are your input values for a sequence? Okay, I'll scroll up there since we're not communicating today. What does it say that the domain is? The set of what? Natural numbers. Natural numbers are what? 1, 2, 3, 4, whatever. So we cannot connect the points with a line, because if we connect them with a line, our input values, our domain, would include decimals and fractions. This is called a discrete function because it's just points. We don't connect it with a line. It's a discrete function, points only. You'll see that word again, discrete function. It's points only, okay? So it says, what is the 21st term of the sequence? Show how you arrived at your answer. Well, remember my sequence equation is a sub n equals 2n plus 1. So if I'm looking for the 21st term, a sub 21 equals 2 times 21 plus 1. And that means that a sub 21 is what? What's 2 times 21 plus 1? It is 43. It is 43. All of your homework questions today ask you to show how you arrived at your answer. So we need to make sure we show our work. You guys see how this is very much like function notation? Instead of f of x, we have a sub n, and you're just replacing the n instead of replacing the x. Do you guys see that? Yes or no? Okay, good deal. Let's go to the next page. So sequences can be defined by a classic function formula, like we just did in exercise 2. And they can also be defined recursively. A recursive formula is one where each term in the sequence depends on the term that came before it. A recursive formula is one where each term in the sequence depends on the term that came before it. So consider a sequence of numbers given by the following definition. This definition right here is a recursive formula. And it's really important that you understand the pieces of it. The recursive formula always has the first term. Always. You always name the first term. And then it says, hey, any number in the sequence is going to be, so it starts off with b sub I, is going to be the number before b sub I. That's why it's written as b sub I minus 1 plus 4. So let's just look at this recursive rule and see what it's saying. Well, what is the first term in our sequence? Because we have to give a common sense interpretation. What is the first term in our sequence? What is the sub 1 term? 7. So this is saying that the first term is 7. And what is it telling us to do to every number after 7? Like, so we take the first term, and what do we do to find the second term? Well, let's just plug it into our equation. If I want to know the second term, I use this formula, right? So I is now 2. B sub 2 equals b sub 2 minus 1 plus 7. But what is b sub 2 minus 1? What's 2 minus 1? 1. And that means b sub 1, it's not plus 7, sorry, plus 4. Plus 4 right here. But we said that b sub 1 is what value? What is b sub 1? It's 7. So we take 7 plus 4 and we get 11. So it's saying give a common sense definition. The first term is 7. Every other term is, what are we adding to it? 4 more than the previous term. That's the common sense kind of thing that we want you to identify. Because remember, it says you have to know the previous term. So every other term is 4 more than the previous term. Every other term is 4 more than the previous term. So it says write out the rule for the first 4 terms, except b sub 1, which is given. And you always have to know where to start. It's always going to have to give you the first term. So b sub 1 is 7. B sub 2 we already wrote out, equals b sub 2 minus 1 plus 4. But b sub 2 minus 1 is b sub 1 plus 4. But b sub 1 is 7. And 7 plus 4 is 11. If I want to find the third term, b sub 3, well, that's b sub 3 minus 1 plus 4. But 3 minus 1 is 2, which means I want the second term plus 4. But you guys just told me that the second term is 11. So I have 11 plus 4, which is 15. My fourth term starts with the previous term plus 4. What is the term before before 4? What is it called it's called b sub what? What is the term that comes before b sub 4? B sub 3 plus 4, which equals 15 plus 4, which equals 19. So that is the rule for the first 4 terms. That's how you have to do that. That's how you evaluate that. I'm going to leave that there for a second to make sure everybody has it. Do you guys see that you're just taking, to find the second term, you take the first term plus 4. To find the third term, you take the one that came before it, the second term, and add 4. The fourth term, you take the third term and add 4. Okay? That subnotation, that subset notation, I minus 1, I know it's confusing, but it's just saying the term that came before it. The term that came before it. Okay. One of the most famous recursively defined sequences is known as the Fibonacci sequence. Okay. So we're going to work with the Fibonacci sequence in the next exercise. He was a famous mathematician. So the Fibonacci sequence is defined as a recursive function. So it says that the first term is what? What is the first term of your sequence? 1. What is the second term of your sequence? 1. It says if I want to find, let's say, the third term, if I let n equal 3, if I'm looking for the third term, well, what is n minus 1? What is 3 minus 1? That means I take the second term and I add it to the, what's 3 minus 2? 3 minus 2 is 1. I add it to the first term. So that's what this sequence is saying. So we have to define it in our own words. Well, the first 2 terms are both 1. Okay. The next term is found by adding the previous 2 terms. So let's just write out some Fibonacci sequence. So if the first term is 1 and the second term is 1, to find the third term, I add the 2 numbers that came before it. What's 1 plus 1? 2. To find the fourth term, I add the two numbers together that came before it. 2 plus 1 is 3. To find the next term, I add the two numbers that came before it. 3 plus 2 is 5. To find the next term, I add the two numbers that came before it. Come on. What are the two numbers? I'm looking for this term right here. What is the sum of the two numbers before it? 8. To find the next term, I add the sum of the two numbers that came before that. To find the next term, I add the sum of the two numbers that came before that. Keep going. 34, right? So it just is going to go on forever. It's going to go on forever. So it says to write down the rules for the third term, the fourth term, and the fifth term, and we have to determine their values. So a sub 3 equals a sub 2 plus a sub 1, which is 1 plus 1, which equals 2. A sub 4 equals a sub 3 plus a sub 2, which equals 2 plus 1, which is 3. The fifth term equals the fourth term plus the third term, which equals 3 plus 2, which is 5. If I wanted to write out the sixth term, what would I say? A sub 6 equals what? What am I going to add together to find the sixth term? A sub 5 plus, yep. And the fifth term, or the fifth term is 5, and the term that came before that is 3, which equals 8. Okay. Sequences often show up in the real world where they are sometimes defined in terms of this recursive process. Kirk is trying to train for a marathon. His first month, he runs 5 miles per workout. He adds an additional 3 miles to his workout for each month that he trains. So fill out this table below for the amount of miles he has been running as a function of how many months he's been training, right? So if I start with 5 miles for the first month, what do I add each month after that? What does it say that he's going to add for every month after? 3 miles, right? So 5 plus 3 is 8. So in mile 2, he's going to run 8 miles a day. Sorry, in month 2, he's going to run 8 miles a day. What about in month 3? 11 miles a day. What about in month 4? And in month 5? 17 miles a day. You guys are awesome. Do you see how that works? Okay, so we have to give the recursive definition for this. So remember I said with the recursive definition, the first thing that you always have to do is tell me the first term. That's how you know where the function starts or where the sequence starts. So a sub 1, when I let the number of months m equal 1, what is my output? When I first started doing this, what was my output? 5. A sub 1 is 5. Okay. So the recursive definition, a sub m equals, well, we're taking the first term, the m term, and we want to find the one that came before it. How do I show the one that came before m? I do -1. Yeah. And what are we adding each time? 3. This is the recursive definition. It has to have the first term and then that function, like you write it as a function. I'm going to also write it in subset notation so you can see what they both look like. So subset notation would be a sub 1 equals 5 and a sub m equals a sub m minus 1 plus 3. Same thing. That first one is in function notation. The second one is subset notation. Okay. The last thing that we need to do is to graph this sequence. We have to graph this sequence on our table over here. So how are we counting on the y-axis? How is each grid being counted? Does anyone see? By twos. Yeah, each grid is being counted by twos. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Okay. So when X is 1 or when M is 1, my output is 5. That's going to go right in between the 4 and the 6. Right there. When M is 2, my output is 8. When M is 3, my output is 11. That's going to go right in between my 10 and my 12. When M is 4, my output is 14. And when M is 5, my output is 17. How do we feel about that?